Welcome, my friends. Something called the determinant of a matrix is a special number that is useful for a number of different reasons, most notably for finding what is called the inverse of a matrix. The determinant can only be calculated for square matrices when the number of rows is equal to the number of columns. The bigger the matrix, the more difficult it is to calculate the determinant. In this video, I will show you how to calculate the determinant of both a 2x2 and a 3x3 matrix. First, let's consider a 2x2 matrix. The determinant of this matrix is represented by vertical lines on either side of the matrix, rather than brackets. I'm using the letters A, B, C, and D here for the general case, but we will apply this to numbers later. The determinant of a 2x2 matrix is AD minus BC. In other words, multiply A and D together and then subtract the product of B and C. Consider matrix B. The determinant of B is 1 times 4 minus 2 times 3. We get 4 minus 6, which is negative 2. Don't confuse the vertical lines around B with absolute value. The determinant is not the same thing as absolute value, but unfortunately the notation is the same. Consider matrix C. The determinant is 5 times 7 minus 6 times negative 4. So we have 35 minus negative 24, which is the same thing as 35 plus 24, which is equal to 59. Hopefully you're getting the hang of it. The determinant of a 2x2 matrix is relatively straightforward. Let's look at a 3x3 matrix, for which the determinant is significantly more time-consuming to calculate. It actually ends up being calculated by finding 3 determinants of 2x2 matrices within the 3x3 matrix. So if we have a matrix with the entries A through I, here is one possible formula. There are actually many ways to find the determinant of a 3x3 matrix, using what is called cofactors, but we will only discuss this more specific and most popular method. Now, it looks a little intimidating the first time you see it, but there's actually a really easy pattern to follow so that you don't need to memorize this formula. Firstly, remember that the vertical lines mean determinant, so here are the 3 2x2 determinants I referenced a moment ago. The way I think about it is, take the very first value in the matrix, what I've labeled A, and then cover up the row and column letter A came from. The entries you have remaining form a 2x2 matrix, EFHI, which is the first 2x2 matrix you need to find the determinant of. The name for the determinant of the special 2x2 matrix you get when you cover up one row and one column is called the minor. Then you must subtract B, and cover up the row and column B came from. You will have 4 values remaining, which form another 2x2 matrix you need to find the determinant of, with D, F, G, and I. Finally, you can add the C value. Cover up the row and column C came from, and then you'll have another 2x2 matrix that you need to find the determinant of, made up of D, E, G, and H. Make sure not to forget to subtract the second determinant. The numbers from the first row of your matrix multiply the 3 determinants, but the second one has to be subtracted. Let's do an example with real numbers. Say we have this 3x3 matrix, which we are instructed to find the determinant of by the vertical lines around the matrix. The determinant of this 3x3 matrix will include the determinant of 3 2x2 matrices, which will need to be multiplied by the values in the first row, negative 2, 4, and 0. But remember that the middle determinant always has to be subtracted, so we actually have negative 2, negative 4, and 0. The numbers for the first determinant can be found by covering up the column and row negative 2 came from, which leaves us with negative 1, 5, 1, and 4. The second determinant will come from the 2x2 matrix we see when we cover up the row and column 4 came from. So now we have negative 3, 5, 4, and 4. The third determinant will come from the 2x2 matrix we see when we cover up the row and column 0 came from. So we have negative 3, negative 1, 4, and 1. Now we just need to find 3 determinants. For the first one, we have negative 2 times negative 1 times 4 minus 5 times 1. For the second one, we have negative 4 times negative 3 times 4 minus 5 times 4. For the third one, we have 0 times, who cares? It will be multiplied by 0, so there's no point in doing the third determinant. This simplifies to negative 2 times negative 9, as negative 4 minus 5 is negative 9. And then we must subtract 4 times negative 32, as negative 12 minus 20 is negative 32. And then we add 0, as 0 times who cares is equal to 0. We get 18 plus 128, which is equal to 146. 146 is the determinant of this 3 by 3 matrix. Let's try one more example. Our three numbers will be 1, negative negative 2, since there's already a negative sign in the formula, and positive 3. The determinants will be of 2, negative 3, 4, negative 4 for the first term, 5, negative 3, 5, negative 4 for the second term, and 5, 2, 5, 4 for the third term. We have 1 times negative 8 minus negative 12 for the first determinant, minus negative 2, which is positive 2, times negative 20 minus negative 15, plus 3 times 20 minus 10. This simplifies to 4 for the first term, because negative 8 minus negative 12 is 4. And then we have 2 times negative 5 for the second term, as negative 20 minus negative 15 is negative 5. And then we have 3 times 10 for the third term, as 20 minus 10 is 10. This simplifies to 4 minus 10 plus 30, which is 24. The determinant of our matrix is 24. All right, my friends, that wraps up our discussion of determinants of matrices.